Okay, we're on data handling still, and in the data handling we are busy with, for this one, I wanted the 5-number summary and I wanted the box and whisker diagram. So when you have the calculator that I would like you to have for grade 12, you can just put it into the calculator and it will give you the answers for the minimum, the Q1, Q2, Q3, what was it, Q4, and then the maximum. That is your 5-number summary for 5 marks possibly. Once you have that, you can go and you can draw your box and whiskers on a number line that has to be according to scale. This is the easy peasy part of maths. You can get lots of marks here. Right, so when I have to go and do my 5-number summary, the easiest ones are the minimum and the maximum. So it has to go from 7 to 25. You don't always have to do both of them, write them, but you've got to work out all 5 of these things to be able to sketch it. If I don't ask you for the 5-number summary, you can in any case going to put it on this graph or the sketch. So I'll be able to see it anyway. So that's minimum and maximum, done. How do I find the median and quartile 1 and quartile 3? Other words for quartile 1 is the lower quartile. And quartile 3 is the upper quartile, because you're going to know what I'm asking you if I ask you for the upper quartile. That is Q3. So you've got to know all those wordings. So if I have to go look at this, I'm counting first of all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 data pieces. The rule with 13 is, where's the middle? That will be the 7th one, right? Because you actually have the 7th one with 6 underneath and 6 at the top. If there were 12, which one would it have been? Between the 6th and 7th one. So in other words, you take whatever the 6th and 7th one are, add them together and divide it by 2. So where is the 7th? 1, 2, 3, 4, 5, 6, 7. Is that 12? That is your Q2 or median. You don't know all the words for it. Then you still need to go get me the lower quartile and the upper quartiles. The lower quartile, how do we do that? So we close it and we say there's 1, 2, 3, 4, 5, 6. So where should it be? Between the 3rd and the 4th. Meaning? Well, it's going to be 9 anyway, and since they're both 9, but you can add them and divide by 2. Same thing over here. Keep it closed. 1, 2, 3, 1, 2, 3. So it should be between 15 and 20, very mathematically done, which will give me 17,5. Are you with me? So that is the answer that your calculator will give you if you have the new calculator, and you just punch in all that data discretely, and you ask it to go to minimum and maximum, because it gives you not only minimum and maximum, but Q1, Q2, Q3 as well. Bargain. You know that you're right. You don't even have to wonder if you were right. So on a number line, you need to go at least from 7 up to 2. Okay, my space, I've put myself in a box here. Can I do this? But then, if there's something that I need to know, I want you to tell me. So I need to see 7. Can I see 7?
Yeah.
I need to see 9. Can I see 9? Rather put it in there. Okay, what I'm saying is, you can be a little bit lazy sometimes, but all the stuff I need to see, I need to see. Okay, so it's rather better to put in all of the stuff. Then you know what you're doing. But also, that's one of the reasons I tell you, you don't just put the little line there for the minimum, you say, minimum is 7. And the maximum was 25. Then nobody can think they don't see it. Then you've got your quartiles, which are longer little lines, namely 9, and then 12, and then 17,5, which I didn't mark down there. But since I'm saying Q3 is 17,5, nobody can say they didn't see it. Also here, Q1 then is 9, Q2 is 12. Bigger box, please don't do it with your free hand like I'm doing. and then also a little line over here, a little line over there. Why is this larger? Are there more things there? No. All the data, exactly 13 of them, has been put into quarter. But the distance between the values are more spread or less spread. Every time I say that, you must remember 25%, 25%, 25%, 25%. Are you with me? If I gave you the sketch, nobody could wonder what it's all about. If I didn't put that there, then you're going to say, oh, it looks to me like 17,3. Okay, so, but then you can't tell the people in the math paper you should do it better. You've just got to use your estimations there. And don't overthink it. Okay, that was your homework. Find me the 5-number summary and draw me the box and whiskers. Then we talked about skewness already a little bit. This would be skewed to the left or right. Where do we look? First at just the box, not the whiskers. In the box already, they're significantly a little bit bigger on the right-hand side. If it was almost symmetrical, then you rather also look at the whiskers. And can it be that a graph can be symmetrical? And it doesn't have to be exactly the same, but it's kind of like close on being the same. Then you just say it looks symmetrical. Remember, estimations. So we would say that this is positively skewed, I like it, or skewed to the right. So you must know both of those ways of answering me, because if I ask you, was this positively or negatively skewed, then you don't say it was to the right. You must answer my question, positively or negatively, then this was positively skewed. Alright, nice easy marks, do you agree? So how many marks could this have been? Let's go extreme. 5 there, 5 there, and even for the skewness, so it's 11 marks for what's going on here. Really? How hard did you have to work for 11 marks in, say, 2 care sums? Because a care sum is around about 5 or 6 marks. Compare? Much easier. So if you're looking for a test, which the first test now is going to be on data, this is where you must make up your marks. There's no excuse for not getting this right. This is like the baby stuff of maths. Okay, let's look at some outliers. If you had to go have a look at these sums, because this is what you've been doing maybe a little bit because of COVID. If I look at that data set with 13 data pieces, do you think there's an outlier?
No.
Why not?
Because
what does an outlier do?
It's that number that's
it's clearly much bigger than the biggest one, or much smaller than the smallest one. Now the smallest one was 7, 9, they're all quite close together. This side, a little bit more spread, but there's not one that's like 21 and then 40. Usually when they ask you identify the outlier, there should be one. If they say, is there an outlier, then it could be yes, there is, or no, there is. Did you hear the words? So in this case, I would have asked you, is there an outlier? And you would say, no. But you've got nothing to verify that. So today I'm teaching you something that almost, you'll remember, I always look at my wording very carefully, almost never gets asked in a matric paper. Well, I haven't seen it in years. You have to calculate why it's an outlier or not an outlier. So there's a formula. So the next little piece here is for maybe, sometimes. And I have seen it asked. It's not that it isn't asked at all. And then it's actually about this whole content. If you want to actually accurately see if something is an outlier or not, you do the following. You look at the distance between your quartiles. So what's that? That's my interquartile range. You look at the interquartile range, but you time it with 1.5. So not once it, but 1.5 it. So that should be a little bit larger than it. Are you with me? Then you take that interquartile range and you get the answer, and you take quartile 1, which is the bottom one, and you subtract from it, and you rather write it this way. Quartile 1, and you subtract from it this answer that you're going to get here. And you're going to take quartile 3 and you're going to add to it the answer that you're going to get here. Then you're going to get like a bigger range. Whatever's in that range is not considered an outlier, but what's outside that range is considered an outlier. That's when we're getting more technical, more precise, but only if it gets asked, which almost never happens. Okay, so first of all, I'll get there just now. I'm just going to get you a basic idea. To find an outlier, there's a formula for outliers, which is that one. So we've got to get the interquartile range. How do we get the interquartile range? It's Q3 minus Q1. Get the answer and time it with 1.5. So that's going to give me a distance. And that distance I'm going to subtract from the lowest one and add to the biggest one. And whatever's out there is an outlier. Are you getting the picture? Okay? So for quartile 3 and 1, where must I get the quartiles? From the box and whiskers, or however I gave it to you. Maybe I gave you the sets and you had to go get them yourself and then you put them in here as well. So that will be 1.5 times worth 34 minus 20. And please show me all the stuff that you do. So that means 14 times 1.5 is how much?
21.
Is 21. Calculator. Okay. What do you do with this 20? Okay, so 21 is the outlier. No. 21 is what you're going to use to see if there is an outlier by subtracting the 21 from the lowest quartile and adding it to the highest one. So if it's below that value, it's an outlier. And if it's above that value, in other words, outside, that should be the outliers. Do you think there's going to be outliers here? Yes. Before we work it out? Yes. Looks like it, eh? Yes. 12, 8 and 4, 10 distance. Oh, lots. I think there should be outliers here. Okay, now also, please remember, I don't know what the exact date is, or data is here, but it's 25%. Say, for instance, it was 20 data pieces, then this would have been 5, 5, 5, 5. So it's not a lot of them that can sit there by the 80. It's only maybe 180. An outlier would also not be an outlier if there's two 80s. The moment that there's two of them, it starts to be a trend. It's not an outlier. So if there's a lot of them in this class getting mathematic data or mathematic points, and you've got an 80 and an 80 and an 80, and then the others were like 34, then they're not outliers because there were a few of them that actually made for a trend. You're getting the idea here? Yes. Normally, there won't be 3 outliers. Maybe if there are 1,000 data sets, there could be 3 outliers because it's so much. But in a normal 10 or 15, 20, 30 pieces of data, how many outliers could there be? 1, maybe 2. Because if it starts getting 3 and 4, then it starts to be a trend, not an outlier anymore. Catching on that. Okay, so let's actually do the maths. I'm trying to get you the logic behind this. So let's see if there's an outlier. So Q1 would be 20 minus the 21 gives me -1. What the heck? So if there was something here by -1 less than -1, it would have been an outlier. So is there one? No outlier. Over here. For that one, Q3 was 34 plus the 21 gave me 55. Above 55? Yes. There are outliers, but what exactly they are, I don't know. I can't just say 80, but I know it's 80 definitely. Because 80 was the highest data piece, I know that. What else is going on here, I don't know. But if it's an outlier, that should mean that the others should be quite more to this side. Because of the interquartile range. That's what it's all about. This is very technical, guys, and if I did ask you for an outlier to actually calculate it, this would be worth like 3 marks, maybe 4. But technically to find an outlier, that would be get the interquartile range, times it with 1.5, 1 and a bit. So you're going to take away and add on that interval, and whatever's outside that, below the lowest and above the biggest, that would be an outlier. In extreme cases, we're going to do one more like that, and that's it. We're not going to concentrate on this because it doesn't get asked a lot. Usually if I ask you, is there an outlier, it will be, there you go. Tell me if there is one or not. You can see it by a mile. In your class, where everybody got 60s and 70%, you're right. And there's one that gets 100, that's the outlier. or that's one that gets 2%, that's the outlier. Are you with me? You don't get 2%. All right, so in this case, how would I answer this question? What would have been the questions? Will there be outliers? Because I couldn't say what is the outlier. For sure, I know that 80 itself is the maximum, the highest data piece, so that would definitely be an outlier. And my inclination then is that it should be the only one, but who says there couldn't be another one in extreme cases? But you can just say, yes, there are outliers. Okay, I'm going back to the previous one. We're going to check if this one has outliers. What did you tell me?
No.
From the start, gut feeling. I don't think so. Let's see if it does good. So let's check for this previous question. Do you think there will be an outlier? We have a gut feeling there won't be. Alright, so it's a stupid question to ask you if there isn't one. But let's play around with the whole fact. If there are outliers, what would the question be? Maybe I should say are there, but then that implies there should be more outliers, and there shouldn't be. How do you do that? First of all, you find the interquartile range, and you time it with 1.5. So you need to find this value. The interquartile range times 1.5 will be the 7,5 minus the 9 times with 1.5. Please give me a calculator answer. Sure? Thank you. So, in other words, what does I do with that 12 now?
75.
Thank you, 12,75. So what must I do with that 12,75?
We'll take you to
Then I must say, if it's below the
Q1
minus that 12,75, or if it's above Q3 plus that 12,75, it should be an outlier. So you can say here, for outliers, this is what's going to happen. So we're going to have Q1 that was 9 minus 12,75, and that's minus 3,75. What does that mean? Anything below minus 3, there's nothing below that, so no outlier. And above Q3 that was 70,5 plus the 12,75 was 30,25. There's nothing. So this one has absolutely no. Not a good question for an exam. In general, you don't only get asked one that you ever have to know the 1.5. But think about it, get the picture. If there's an outlier, you're basically looking at your box, which is 50%, but you're taking that distance, basically, and timing it with 1.5. So that gives me that distance and a bit on either side. And if it's outside of that, where you subtract and add that value, then if it's outside of that, it's an outlier. Not an outsider, an outlier. Are you with me?
Yes, ma'am.